Hello everyone, welcome to ASPEAK. Today we are going to talk about photoelectric effect and dual nature of matter and radiations.
The topics in this chapter are: what are photons, what is photoelectric effect, detailed study of photoelectric effect by experiment, effect of frequency, intensity, potential on photoelectric current, graphical representation of variation of photoelectric current, laws of photoelectric effect, Einstein's photoelectric equation, verification of laws of photoelectric effect based on Einstein's photoelectric equation, applications of photoelectric effect, matter waves, and de Broglie wavelength, the most important part in this entire topic, Davison and Germer experiments. So let's start. The photons. A packet or bundle of energy is termed as a photon. Now, when we study photons, okay, we need to understand that energy of a photon is resembled by E, which is capital E. Okay, this E is equal to hv, where h is the Planck's constant and v here is the frequency of radiation of photon. Okay, it is also equal to hc by lambda. Here h is your Planck's constant, c is speed of light of electromagnetic wave, and lambda is the wavelength. Let us study photons' properties. A photon travels at a speed of light c in vacuum. Now what is the speed of light in vacuum? 3 into 10 raised to minus 8 meter per second. Then it has zero rest mass. That means photons cannot exist at rest. The kinetic mass of a photon m, I mean small m, is equal to E by c square, where E is the energy of the photon and c is the speed of light in vacuum. It is also equal to by c lambda, okay, because we divide E by c square. So according to that, it is h by c into lambda. Okay, then photons p, it is equal to E by c. Okay, energy of photon divided by speed of light in vacuum, equal to h by lambda. Okay, photons always travel in a straight line. Energy of photon depends upon frequency of photon. So the energy of photon does not change when the photon travels from one medium to another medium. The wavelength of the photon changes in different media. So since the wavelength changes, the velocity of the photon is different in different media. Photons are electrically neutral. Photons are not deviated by magnetic or electric fields. Phenomenon of emission of electrons from mainly a metal surface exposed to light energy. Light energy may be in the form of X-rays, gamma rays, UV rays, visible light, even your infrared rays of suitable frequency. That is photoelectric effect. Now the electrons emitted by this effect, photoelectric effect are termed as photoelectric electrons or photoelectrons. Constituted by the photoelectrons is hence termed as photoelectric current. Non-metals even show photoelectric effect. Liquids and gases even show this effect. But then in liquids and gases, this effect is very limited extent. Okay. When we study about metals and alkali metals, we see that photoelectrons get emitted. But when we study about metals other than alkali metals, we see that there is no photoelectron emission. Understand the effect of frequency of incident light on photoelectric current. Now, effect of frequency of incident light on photoelectric current can be studied as: for a fixed intensity of incident light, the photoelectric current does not depend on the frequency of incident light, because the photoelectric current simply depends on the number of photoelectrons emitted and in turn on the number of photons incident and not on the energy of photons. Okay. Effect of frequency of incident light on the stopping potential. Understand how this effect of frequency of incident light works. So for a fixed intensity of incident light, the photoelectric current increases and is saturated with an increase in positive potential applied to the anode. However, the saturation current is same for different frequencies of incident lights. When potential is decreased and it's taken below zero, photoelectric current decreases to zero, but at a different stopping potentials for different frequencies. Effect of intensity of incident light on photoelectric current. Let us understand graphically. Incident light current. So we come to understand that for a fixed frequency, the photoelectric current increases linearly with an increase in the intensity of incident light. Effect is effect of potential on photoelectric current. In intensity of incident light, the photoelectric current increases with an increase in positive potential applied to the anode. When all the photoelectrons reach the plate A, current becomes maximum and it is known as saturation current. Since when the potential is decreased, the current decreases and does not become zero at zero potential. We understand that even the absence of accelerating potential, a few electrons will be able to manage to reach the plate due to their kinetic energies. That means these photoelectrons have such kinetic energies which can help it accelerate itself to reach to the plate. When negative potential is applied to the plate A with respect to C, we see that photoelectric current becomes zero at a particular value of negative potential. This potential is called cutoff potential, threshold frequency. So this graph between the stopping potential and frequency does not pass through the origin. This shows that there is a minimum value of frequency. This minimum value of frequency is called threshold frequency, below which the photoelectric emission is not possible. However, high the intensity of incident light may be, it depends on the nature of the metal emitting photoelectrons. Let's see what are photoelectric emission laws. For a given substance, there is a minimum value of frequency of incident light called threshold frequency, below which no photoelectric emission is possible. Howsoever the intensity of incident light may be. Electrons or photoelectrons, the number of photoelectrons emitted per second is directly proportional to the intensity of incident light provided the frequency is above the threshold frequency. Third law, the maximum kinetic energy of photoelectrons is directly proportional to the frequency provided the frequency is above the threshold frequency. Fourth law, the maximum kinetic energy of photoelectrons is independent of intensity of incident light. Emission is instantaneous. Next law is the photoelectric emission for every photon is suitable of a suitable frequency, one electron is emitted. Electric equation, energy Hv on a metal surface. The energy of photon is absorbed by the electron and is further used in two ways. To overcome the surface barrier and come out of the metal surface. This energy part is termed as work function. So work function is equal to hv naught. Work function flux is equal to hv naught. The remaining part of the energy is used in providing a velocity v to the emitted photoelectron. This is equal to maximum kinetic energy of the photoelectron. So half mv square max, where m is the mass of photoelectron, is equal to h v minus h v naught. Energy hv is equal to flux plus electric emission loss based on Einstein's photoelectric equation. Now half equals h into v minus v naught. If v is lesser than v naught, then half mv square max is negative, which is not possible. Therefore, for photoelectric emission to take place, v greater than v naught, as one photon emits one electron. So the number of photoelectrons emitted per second is directly proportional to intensity of incident light. It is clear that half mv square max is directly proportional to v, as h and v naught are constant. It is clear that half mv square max is directly proportional to v, as h and v naught are constant. This shows that kinetic energy of photoelectrons is directly proportional to the frequency of incident light. Photoelectric emission is due to collision between a photon and electron. As such, there cannot be any significant time lag between the incidence of photon emission of photoelectron. Okay. So this process is instantaneous. It is found that delay is only of 10 raised to minus 8 seconds. So the first application is scanners in television transmission, reproduction of sound in cinema films, third, in paper industry to measure the thickness of paper, fourth, in astronomy, fifth, in determining opacity of solids and liquids, fifth, automatic switching of street lights of furnace, eighth one is photometry, the next one is to measure the fair complexion of skin, next is photoelectric sorting, then comes photo counting, and then comes meteorology. Photoelectric effects applications, scanners in television transmission. Wave theory of electromagnetic radiations explained the phenomenon of interference, diffraction and polarization. On the other hand, quantum theory of electromagnetic radiation successfully explained the photoelectric effect, Compton effects, black body radiation, X-ray spectra, etc. etc. Thus, radiations have dual nature, wave nature and particle nature. Louis de Broglie suggested that the particles like electrons, protons, neutrons, etc. have dual nature. Very important point to note here is, in no experiment matter exists both as a particle and as a wave simultaneously. The two aspects are complementary to each other. What to study this? Let us understand. According to de Broglie, a material particle in motion can be associated with a wave because a wave can guide the motion of a particle. The wave particles are known as de Broglie waves or matter waves. Equation for de Broglie wave is, according to quantum theory, the energy of a photon E is equal to hv, which is also equal to hc by lambda. We studied just some time back, right? So, according to Einstein's theory, the energy of photon is E equals to mc square. So, lambda is equal to h by mc, or lambda is equal to h by p, where p is equal to mc, which is the momentum of photon. Instead of a photon, we have a material particle of mass m moving with the velocity v, of the resultant here is lambda is equal to h by m into v. De Broglie wavelength is inversely proportional to the velocity of the particle. If the particle moves faster, the wavelength will be smaller and vice versa. If the particle is at rest, then the de Broglie wavelength is infinite. Such a wave cannot be visualized. De Broglie wavelength is inversely proportional to the mass of the particle. The wavelength is associated smaller than that with the lighter particle. De Broglie wavelength is independent of charge of the particle. So matter waves like electromagnetic waves can travel in a vacuum and hence they are not mechanical waves. Matter waves are not electromagnetic waves because they are not produced by accelerated charges. So matter waves are probability waves, amplitude of which gives the probability of existence of the particle at that point. This angle of 50 degree is what I am talking about, angle of scattering. And the accelerating potential hence is 54 volt. Therefore, theta plus 50 degree plus theta is 180. So for a nickel crystal, lattice spacing D is equal to 0.91. So for the first principle, N is equal to 1. Electron diffraction is similar to X-ray diffraction. Therefore, Bragg's equation 2D sin theta is equal to n lambda gives us lambda is equal to 1.65 ampere.